A positive charge, Q1, equals 25 microcoulombs. And let's recall, what does micro mean? Micro is 10 to the minus 6. Okay? That's located at point x1 equals minus 8. And then here's Q2 on the number line, and here's Q3. Draw free body diagrams for the electric forces acting on Q1, Q2, and Q3. Okay, well, let's do this here so we can fit better. Q1 is a positive charge, Q2 is negative. So let's start with Q1. Q2 is going to try and pull it that way, right? So that's going to be the force that 2 exerts on 1. Q3 is positive, so that's going to try and push Q1 this way. So that will be the force that 3 exerts on 1. Now let's go to Q2. Q2 is negative. Q1 is positive. It will attract Q2. So that is going to be the force that 1 exerts on 2. Q3 over here is positive. That also will attract Q2. So that'll be like this. That will be the force that 3 exerts on 2. And finally we'd go to Q3, and I've kind of run out of room there, but you can hopefully see that Q1, which is positive, will try and push Q3 that way. So that will be the force that 1 exerts on 3. 2 is negative, so that's going to pull Q3 this way. Now before you worry that you can't really see that too well, let's just pull the answer out and make sure that's exactly what I drew, and yes it is. So please pause here for a second and make sure you can reproduce those diagrams. Step 2 now has 3 different parts, and we're going to find the magnitude of the force between Q1 and Q2, because they act on each other. Then also between Q1 and Q3, so there's 2 forces we have to find. And what's the only other force we need now? Well, Q2 and Q3 exert forces on each other. So there you go. So we have 3 calculations to do using Coulomb's law. And fortunately, we have that over here in the answer. And I'm just going to go ahead and pull that out so I don't have to rewrite all that stuff. And here's the force that 1 exerts on 2. And of course, the force that 2 exerts on 1 is the exact same magnitude. So we get 2 things calculated here for the price of 1. We put in Coulomb's constant, 9 times 10 to the 9th. We put in the magnitudes of the charges. We don't care about negative or positive here. We just want to find how big it is. When we get back to our free body diagrams, that tells us whether to make it a positive or a negative force. And then here's the force of 1 on 3, which is also the force of 3 on 1. We put all the charges in there, the distance, and at this point you should be able to count the distance between the charges on the number line. We get a force there, and then finally this is the force that 2 exerts on 3, the magnitude of it, not the direction. Now we need to find the magnitude and direction of the net force on each one of these charges. We certainly found the pairwise forces on the previous slide, but each one of these charges has 2 forces acting on it, so we have to do vector sums. So let's pull out the work here, and let's see if we can fit it there. Perfect. And first we're going to start with the net force on Q1, and we're going to call that F of Q1. That's the net force on Q1. Well, we know that's equal to the sum of the forces that charge 3 exerts on charge 1 and charge 2 exerts on charge 1. And we reference our free body diagram, and we find that the force of 3 on 1 is to the left. 3 is repelling 1, so that gets a negative sign. F21, charge 2 is attracting charge 1 to the right, so we get a positive. So we add those together, and we get a positive answer, 1.17 times 10 to the negative 2 newtons. Since it's positive, we then say the force is directed to the right. And we proceed in a similar fashion for Q2 and Q3. So here's Q2, it's the force of 1 on 2, and since that's in to the left, right, because Q1 here is pulling Q2 to the left, we give that a negative sign. Charge 3 is pulling it to the right, that's positive. We add numbers, and once again we get a positive number, so the net force will be to the right. And notice, look at this. This here is the same number. The force of 2 on 1 and the force of 1 on 2 are the same. See how the magnitudes are the same there? So we don't have to do the calculations again. But the signs are different because of the configuration of the charges. And finally, the force on Q3. Force 1, charge 1, is pushing it to the right. That's positive. And we have charge 2 is moving it to the left. That's negative. We add them, and this time we get a negative net force. Therefore, the net force is to the left.